Hello. In this second part of the case study on activity monitoring, we'll be going through a brief demonstration of a smartphone based activity monitoring system. So it's a very basic setup. That means we have a smartphone with us, we have a remote server, and we have a network. Nowadays smartphones are as good as computers, laptops, PCs. So, and in fact, in some cases, they are even more powerful than traditional PCs. So, what we are planning on doing is, since everyone carries a smartphone nowadays, almost everyone is using a smartphone nowadays. So, we are going to use the inbuilt sensors, and we are going to try to transmit the data from the smartphone sensors over the network to a remote server on which we can visualize the incoming data. So for this part, we haven't explored it that much, but judging from the preliminary successes, we predict this has a huge potential, and if properly worked upon, this can be easily integrated with standard or traditional IoT based technologies, even in smart homes, smart offices, smart buildings, transportation, and everything. So your decision making, what we are proposing, you do the decision making at the server end, you just transmit the data from the smartphone over the network to the remote server. Now, before beginning, I'd like to just brush up on a few things. So I hope you all know that your smartphones are built in with certain sensors. More specifically, you have your accelerometers, which are in every smartphone. Higher end smartphones will also have compass and a gyroscope. So compass or magnetometer, it will give you magnetic readings with respect to the true north, and your gyroscope will give you the orientation of your smartphone. So for example, your accelerometer will give you the readings of acceleration. So suppose in case of sudden jerks, like this smartphone is traveling with you, so in case of sudden jerks, this accelerometer will generate a higher impulse response. In case of gyroscope, if your smartphone orientation changes, even if there is a tilt or angle or any such other change, the gyroscope will record this, and your magnetometer, which will be responsible for locating the direction you are moving with respect to the north. And additionally, almost all smartphones are equipped with GPS. So you have 4 very basic sensors found in almost all smartphones: your accelerometer, gyroscope, magnetometer, and the GPS. So using a combination of these 4 sensors and maybe the internal clock of the sensors, internal clock of your smartphone, and the network attaching capability. That means since your smartphone has already been enabled with a cellular connection or a Wi-Fi connection, so you can choose either any of these 2 connections to transmit your data over the network to a remote location. So this was about the smartphones. We are not going into the details how we are transmitting the data, which network we are choosing. For this, for our demonstration purpose, we are choosing a local Wi-Fi network over which the server is also connected, and the server is remotely located. I'll be using my desktop to access that server remotely, and I'll be trying to log into my remote server via an Android app so that the data can be transmitted directly. So I have my Android app. I have connected it to the Wi-Fi network. I open this app. We have just named it iRaid. So it has got 3 fields. One is username, one is the IP address of the server, and one is the port. So if you remember that those lectures on IoT with Raspberry Pi, so we were also using 2 basic things. One was the IP address, another was the port. So Over here also we are using these two, the IP of the server and the port onto which your data will be uploaded. And we have got two buttons, one is initiate and one is stop. So over at the server end, I'll start my Python server. So this web server was made on a library function, Python library function for WebSockets. It is known as Autoban, and using this Autoban and the twisted framework, we created this WebSocket server. And similarly on this Android phone, the Android programming for this application was done using the same manner. So I give my server IP address as and the port name is same. I'll provide some username, right? So whenever I initiate my connection, first you look, the server is actually expecting connections. So whenever I initiate my connection on the smartphone, text message pops up, connected. And if you focus on the server end, you'll see the data is being logged onto the server. So it has got a few fields. First is the date field on which the data is being collected. Next is the time. Then third fields we have kept intentionally blank. And for this demonstration purpose, we are only logging the accelerometer values. So if you see, I give it jerky moments, the values abruptly change on the server end. Additionally, we open another link to the server and we open a plotting function. So on one thread, the data is being uploaded over the network from the smartphone, remotely located smartphone. On the other thread, we are running a plotting function. So if you see on the screen now, a plotting window pops up. So since nothing is being plotted here, I might need to change some parameters. So now my data is being continuously logged onto the server. So this is my plotting function. I run the plot program again. You see these three lines. These denote the accelerometer X, Y, and Z readings. So if you see, if I move my smartphone, these lines go up and down. So this, we have not tried filtering this data. We are trying to plot it as it is coming into the server. There has not been any delay element added to it, nothing. Just the raw sensor values are being plotted. So one thing you can derive from this is, suppose your smartphone is kept on a level area. So you see your x-axis, y-axis are more or less on the same plane, nearby each other, and the z-axis gives a reading of 10. So this basically signifies it is at certain distance from the ground, right? It is not at the 0th position or the same as x and y axis. So whenever I change my, maybe I tilt my phone, if you see on the screen, the blue line goes up. That means the x-axis of the smartphone changes, right? Now whenever I tilt up the phone in this manner, you see my z-axis goes down, so it is much more nearer to the ground, whereas my y-axis goes up, right? So y-axis reading has changed. So basic primary application which can be derived from this is, maybe this can be used as a level tester to check whether your levels are correct or not, whether your maybe you are supposed to put everything parallel to the ground, but you need some kind of level testing device which can tell you the measurements. So this may be one potential application. Other potential applications may include using these sensors and combining them with various machine learning algorithms. So for that you need a prior or historical data on which your various machine learning algorithms will be trained for supervised learning. On the basis of that, you can go for activity detection also. This is only just monitoring of activities. We are not giving out any kind of intelligence whether this phone is okay or not, whether a person holding this phone is sitting down or standing upright or lying down. So those kind of things can be additionally added to this framework to make it more robust, more reliable, and much more functional. So one is basic activity monitoring. Another application can be, which can be very useful, is fault detection. Like we discussed in the previous lecture, for medical patient monitoring, you need fault detection approaches, you need emergency alert approaches, and so on. So maybe using this, you can detect a fall, and after a fall has been detected, various emergency services can be alerted. You can even provide a feedback from the server after a fall has been detected. The server will ask the phone user whether you have actually fallen or not. So that may be miscommunication from the sensor, or that may have been due to an accidental jerk or sudden bump. So if the user is in a condition to respond, then it is fine. So user says no. If the user is not in a condition to respond, so maybe something has gone wrong, and emergency services, hospitals, relatives can be alerted. So these are some of the basic implications and applications which can be developed using this framework and this approach. So it's actually limited by the user's imagination what else can be done. So I hope this has been useful to you. Thank you.